Hello guys, thanks for stopping by again. I finally carved out some time to present you with something that I've been working on in the last couple of weeks apart from my full-time job and assignment. A couple of hours a day has been enough for me to put together a functional website. Currently it's a blog, just a blog. I've been planning for doing in quite a long time. Now it's ready. This link actually works now. You can follow this link. It'll bring you to my website. A couple of articles already written about it. This one is the newest one that I've just put together. Something that we're gonna be talking about today, but not. I'm not in that level of details. You definitely wanna, if you wanna like learn more, if you wanna follow my thought process, feel free to visit the website and read the article. There's like a plenty of links with like solutions and technologies that I used in my stack, which I'm gonna highlight briefly. Don't worry about it. But the whole purpose is just to demonstrate some diagrams and some demo in a way how it works under the hood, something you can really do in a video format rather than text. So let's do it. All right, but before I do any of that, I want to address a very important point. I want to answer one question that everybody's probably who's watching wants to ask me right now. Like, why would I ever do that, right? Like, there are plenty of tools right now out there that can build websites in a matter of hours, if not minutes, right? There are AI tools that you can like prompt to that would build entire website front-end stack for you, available on the custom domain name or something, right? All right, I get it. Solutions are there. But my reasoning approaching this in a kind of hardcore way by building it myself and hosting on my custom domain name in the cloud, because I wanted to learn. I wanted to learn first. And I wanted to also understand, sure, I use AI during the process for research, for autocomplete, for writing code for me, at least pieces of code, right? For fixing bugs at times. Sometimes it worked, sometimes it didn't. Well, my reasoning is that you got to understand, like at the moment, the best thing you can do to stay competitive is to understand what AI is good at, right? Like you got to understand something that makes you a better like specialist, a better employee, right? Like so that you can contribute to the community, to the company, with the skills that differentiate you out of the crowd, out of the systems and technologies. You got to understand your strong side. That's my point. So I've made time to learn about it and to actually build something with hands, something functional. And I think I've got tons of learnings out of it. I'm ready to share it with you. Let's do like real architects do. Let's discuss the requirements. And for the sake of this video, I made a single list of requirements, simplifying a lot of things, actually combining both functional and non-functional ones for it to be a little bit like simple, engaging, without unnecessary complexity. So let's go through it. Developer experiences was the number one thing that I was thinking of. And it's really important. Like people talk about these days, right? People want it these days, like big tech companies trying to do something. And it wasn't an exception for me. So I needed things like convenient debugging, provisioning, less kind of management, less operations, because I know that it is like really distracting. So you don't want to like deal with lots of infrastructure management, like permission management, so to speak, right? So I was looking for something that would, for a tool that would do it for me so that I don't have to. Those are the things like local debugging, but also like debugging your environment while it's provisioned in the cloud, even partially. It's still a contribution towards you spending less time in the future, kind of managing it, troubleshooting it in the cloud, relying only on the logs, right? You basically, we like what we're trying to achieve here is we want to kind of narrow the gap between the differences of a dev environment and the production environment. But then on the other side, we've got user experience. And I'm going to let you on a little secret here, because for front-end applications, it's just mostly performance, right? How fast your website loads up, right? How heavy is it? Like, does it optimize images, other static assets, right? Really, like how fast a user is going to load your website. So the time of a first byte, so to speak, and how fast is or smooth is going to be his experience on the website by navigating through it, by like looking through things, by finding information fast enough, okay, getting to the point. So those are the things that become matter. And I was looking for, again, some solutions for that so that I don't have to kind of like reinvent the wheel from scratch, because so many wheels have been implemented so far. You just have to choose the right one. And of course, as an AWS guy, I wanted it to function out of AWS. I wanted to see how much of a fit AWS is for that particular thing. And again, front-end app, but it's in a sense a full stack application containing like server components, as I learned that a front-end app, a modern front-end app or Jamstack, which we'll talk about in a sec, contains server components because it's becoming like important, because you need like server compute to process things faster for better user experience, so on and so forth. Okay, so there's like a server side of things. All right, but it's also, there's a data tier as well, because I need a couple of databases. I need data store, non-SQL, data access pattern, and object store as well. So AWS has all it, and it's been offering it for quite a while. The quality of services are improving, API is improving. So I wanted to see like how much of a hassle is it to manage things in the AWS, like something like a modern full stack application. Fast time to market partially comes down to dev experience, because the faster you go, the earlier you will be at the destination. But not only that, because once you've nailed things in the dev environment, could be your staging or testing environment, call it whatever you want, you'll have to start thinking about productionalizing things. And that will involve like removing convenient debugging like support from your application code bundle, okay, while adding some extensive observability features like extensive monitoring, logging, and all that, for you to be able to support things in production without ditching performance and user experience, so to speak. Okay, a Jamstack, what it really is, if you're a front-end developer, I bet you know it. It's been there for quite a while. So I've got the link here. If you follow the link, it actually describes it quite well. Architectural approach decouples various layers, web, data, business logic, improving flexibility, scalability, performance, and other things. I get that. But at the end of the day, they are like frameworks out there that implement Jamstack in various ways, and all comes down to other things like choosing the right one for you. A couple of things that when I did them, it felt like I wasn't doing the right thing. I mean, UI is not really my thing, so another time I'd probably find a person to do it for me. But in order to put together a full stack application, you still need to understand the fundamentals, even to carry out a conversation, a productive conversation with someone who is doing that, right? You're going to understand a couple of things about CSS, about component libraries, how to link it in code, the compatibility issues, right? But for me, the requirement was to kind of like find a good example and borrow the approach from there, like in being able to use same components, same kind of style, same fonts in my particular website. Next on the list, resiliency and security. Those are production readiness things. You really want to make sure that they are in place before you expose your stuff to the users, but also even for staging environment, right? You don't want it to be accessible freely, in the internet, like especially your source code, because your source code can get leaked and it would expose a lot of things to hackers to operate off of, which will increase their chances to hack your actual production environment with user data. So you really want to think about it in advance, choose the right services. In case of AWS, that would be the right managed services, the way you configure them, following best practices. That's what I had in mind on that stage. The next important thing for your production environment is observability, because remember, you don't have those convenient debugging capabilities in production. For a number of reasons. You don't want to just simply step into the breakpoint and lock an execution thread of your service, resulting in your user seeing something like a frozen interface or something, right? You don't want that. Neither you want to increase the bulk of your distribution package, resulting in longer loads and like a slower performance. So you really want to make it so your production runs as fast as possible, excluding all unnecessary things, but still having enough data about your service running for troubleshooting and optimization purposes. And those would be things like extensive logs, especially in the initial stage. You don't want to exclude debug logs. I think you want to rely on them. Extensive metrics covering all sorts of, both application and infrastructure related things, and traces, given that you've got multiple services running. When you start decoupling things, some like Lambda function running in background, well, in those situations, you want to also have some like traceability of your system. Scalability is not very important initially, but it will become important as the number of users increase and they start extensively use your service. So you better make sure that the architecture is so that it's scalable enough, right? It's decoupled enough. It's not going to cause any bottlenecks, any problems here and there. And you can kind of scale various pieces of architecture independently. Software architecture, sort of like related to dev experience. If you do your software architecture right, it's kind of like you're moving faster. You don't have to like refactor a lot of things. So you better like put in some time to think about how you want to like decouple your packages. I recommend sticking to DDD, domain-driven development, and hexagonal architecture, I believe. So there's like a core package, and it can be built independently. It doesn't depend on anything, and there's other packages implementing these core functionalities you have. And the good benchmark results. But how can you know that in advance, really, right? It will depend on so many things that you do in your project. Well, whenever you are choosing a tool, a piece of technology, a library of such, they probably outline it in the doc, confirming that, comparing it with something else. They probably have references to fully implemented solutions you can rely on. You can even run an independent test yourself against another website that's built on a particular piece of technology. That could be all very helpful, but my motivation was, okay, I wanted to choose something modern that like with a big community, with people saying that it's fast enough. And I just wanted to use the same thing and see whether it works out for me in the end. And I don't want to get deep into the technical choices that I made during the design phase, but I do want to point out one very important and quite capable thing here. And that is this SST framework. And if you know CDK, AWS CDK, so AWS is built on top of it. A CDK basically allows you to manage infrastructure in the AWS ecosystem using or relying on general languages. So we basically describe your infrastructure using so-called constructs through various language libraries in code. You can leverage as many known code abstractions as you wish, such as loops or cycles, conditions, all of it, right? And CDK will do the rest of the work for you. It's good if you are building something fast, if you're prototyping, if you've got the skill and that the only skill is, say, TypeScript language, well, you can also cover infrastructure with it then, and people choose it for that matter. Under the hood, it transpiles into CloudFormation. CloudFormation is not my favorite infrastructure as code tool, but the good thing is that I don't have to think about it because CDK transpiles into it, and then the rest of it just like interacting with the like console or CLI, just watching whether the CloudFormation is doing the right thing. The good thing about it, in fact, is that you don't have to manage state. CloudFormation state is managed for you, and you don't have to pay for it. All right. So, and the SST is like another layer of abstraction on top of CDK. It reuses those foundational constructs, okay, adding another additional features on top of it. And let's go through them real quick. And if you go to the docs section of their website, you'll see straight off the bat that they cover a bunch of popular frameworks such as NextJS, Remix, and others, giving you a good point of comparison between them. I was looking for a solution that would help me deploy it in AWS Cloud. So initially, I wanted to do the static website hosting, and Next.js, in fact, provides you with such a capability to export a project as a static website package on condition that you're not using every single capability that Next.js provides. That would require server-side rendering, okay? So I put together this stack using pure CDK at that point, and it worked. It came out with a couple of issues such as lack of middleware, so you can't do like redirects. You can set it up. There's no like server router that would do it for you, and the user who is going to the website, they need to know exact kind of like file name extensions that are hosted in this S3 bucket, right? So the workaround that is just to front this CloudFront with a Lambda edge that would do the rewriting rules, so that if a user requesting one file without an extension, would the CloudFront would actually think that it's an extension once a Lambda edge does its work. Okay, so what I didn't like is that it would have taken me more work on putting this stack together. And I thought I would just as well figure out a proper, like a server-side hosting. So, and I found this, the SST actually made a big difference. Not only it provides with a very kind of smooth onboarding experience for your Next.js project, you can actually go ahead and just inject your SST into the existing project without needing to hustle around the like software architecture, the project structure. It would just work most likely. But in order for it to be scalable, you probably want to do a standalone project, which where they kind of showcase the best practice of organizing your project with like a workspace environment with packages, decoupled packages of sorts, right? So they also kind of equip you with like some good practices that would make you go a long way when building out your solution. They offer a number of great abstractions that will help you a lot when you build something out, something you'll have to think about anyway. So they've got you covered here. Like config management, for instance, right? The way you configure your apps, the way you like manage secrets. So they provide you with a way to define your like parameters and declare your secrets in the infrastructure portion of the project. You can store the secrets using your CLI, using the CLI tool, and you can use the secrets, consume them in your application portion of the project using corresponding like libraries that they offer as well. It's quite convenient. And the way they manage permissions is through so-called like resource binding. This is the way to define that one resource depends on another, and the framework will figure out the least permissions needed for a job to be done. They also offer this live Lambda debugging experience. This is basically the way to connect to remote Lambdas running in the cloud out of your local IDE in a debug mode. Like super convenient. They achieve it through IoT WebSockets. Turns out there's like endpoint always available in your AWS project you can connect to. So they implement this live Lambda development through that. And it's been quite interesting to learn about, to be honest, and also quite convenient to use, I gotta say. They also offer a bunch of like advanced features for monitoring Bootstrapping, something you have to think, like Lambda layers actually used it for Lambda Insights. I in fact leverage it to bring it to life. And a bunch of other very interesting things that you may want to consider using as your project grows. All right, guys, the next thing I want to do is I want to demonstrate you a systems architecture of a deployed thing. This is what you're going to get in your AWS environment once you deployed your Next.js application stack with SST. My version is a little bit modified, extended in a sense, because I'm adding this additional data stack that is shown in the bottom part of the picture. That is because it's a reasonable architectural decision to keep things separate, to have this separate persistent layer, so to speak. So I have two data stores here for my Notion, for my exported Notion blog posts. Okay, the DynamoDB table is for the metadata stuff like URL, title, when the page was modified, when it was created, something that is valuable to display to end user in the website as well. So this data gets here. And the S3 is for heavier resources, heavier assets, so to speak, the pictures. I'm exporting pictures from Notion as well. I'm downloading it using fetch, regular fetch, and I'm storing it in their original form in this S3 bucket while also exposing through the CloudFront distribution associated with another domain name. So the website, it knows about those resources by looking into this DynamoDB table and aggregating information about the pages exported. And I'm also kind of generating the links pointing to the pictures through this like internal route with this dedicated domain name. That is also something you have to configure for the website to be able to allow your client's browser to consume resources from another domain name. That is called CORS, cross-origin resource sharing, and that is just one directive you have to configure in your Next.js server configuration. When it comes to the Next.js website, it's worth noting what AWS resources are represented. I tried to consolidate them in this box above, though it's not everything, but most important one. So let's break it one by one. Similar to the data stack, static assets get exposed through the combination of an S3 bucket and CloudFront distribution, though this time they are exposed through the primary domain name, which in my case is ilaslobin.com. CloudFront distribution defines the behavior and through various and different path prefixes, redirecting portion of them to this S3 bucket to serve to the client. An interesting thing about Next.js project is that it generates static pages as long as you define a criteria how parameters in the router are defined. As long as you can define it, prior to the compilation, during the build, those pages will be filled in with data will be generated in form of various JavaScript files so that they can be served off of this S3 almost instantly, right? It's going to be very fast. But it will remain so that your server-side portion of a Next.js project will still need be computed ad hoc. And for that, what OpenNext, and that is a framework that is running on top of Next.js but below SST, the SST makes use of an OpenNext to translate this Next.js project onto the AWS infrastructure, so to speak. So OpenNext is in fact converts the server side, the Node.js portion of it that is you're normally running in your either on your local machine or on a web server, right, in Kubernetes and container, whatever. So in this case, in the case of an OpenNext, it's in fact it's served off of the Lambda function, and you can choose what kind of Lambda function to use for that. There's a choice between the original one. In that case, if you deploy, it's actually default choice. If you deploy it this way, it's gonna come out as a Lambda URL. So publicly exposed, be careful about that. So you wanna eventually protect it with authentication. It's also possible. They instruct you how. But with introduction of just one parameter, you can make it so that the Lambda is going to be deployed on the edge, and your sort of like a website is going to be served off of like all available 650 plus points of presence that AWS has. On top of that, there's also an option. AWS has a service wavelength, and that is basically 5G infrastructure represented in big major cities of United States, Europe, and Asia. So with just one request, you can make it so your Lambda edge will like span out further down to these 5G edge compute, and will be served off of those points of presence. So far, we've covered this portion of the diagram. Forgot to mention there's also an image optimizer function, the purpose of which to make images smaller that get served to your user. So whenever a user is requesting a website, for instance, from their mobile phone, the viewpoint, the size of their web browser is much smaller. So you don't necessarily have to serve full images to them, because network time bandwidth, it results in a very kind of slow loads and bad user experience. So there's image optimizer function for that leverages some low-level, highly efficient, probably C++ backed libraries. That is the purpose of which is just to compress original images and serve it off of the CloudFront distribution. So whenever the user requesting them of particular size, that's what's going to be served, and even more so if like other users are accessing the same images from similar devices, the images could be eventually reused as per their algorithm, which is quite convenient, obviously, saving you a whole lot of compute. There's also 3 elements on the top that represent the revalidation functionality. They function in tandem. That is a global dynamic DB table, SQS queue, and a Lambda function itself, the purpose of which is to trigger invalidate function on the CloudFront distribution whenever it feels the need for that. Lastly, I want to highlight this portion of the diagram. So a couple of things that you haven't included into the stacks, but they get created anyways along with them. Those are they're not shared. They come as a part of every stack virtually. So every Lambda function generates logs, and those are available in CloudWatch. You can customize the behavior, the way our logs are like where they get sent to, into what groups, and so on and so forth. You can also additionally create metrics based on the logs. There's such a functionality in AWS if you're interested. But the Lambda, there's like Lambda rotation that removes the old logs that aren't relevant anymore. You can control this behavior through SST configuration as well. IAM, obviously. So every single resource here gets the least necessary privileges to do their thing, and the framework is smart enough to control it through various IAM policies and roles. And finally, guys, a demo as promised. Especially if you want to support it alone or in a small team, you want to have a way to control it as a monolith repo, okay? Because it just makes things so convenient. So here I've got my various pieces of the systems architecture and in the form of packages, and they are connected through npm workspaces, right? So I've got the workspaces so that I can interact across these packages whenever I feel the need for that, and then I can even like simply refactor it back and forth, moving elements. Actually, it's a good DDD design. So we've got your core functionality in the core package and the other functionality in other packages. There's web package, that's for Next.js, but I want to pay attention to these the upper kind of like layer of this project, and that is going to be SST. SST is going to control your system architecture. So what I've got here is just this high-level definition file with importing a couple of stacks here. There's and they come in order. They have to be deployed in order for it to work. All right. So the config stack is that where I define the like various configuration parameters, and as you can see, I'm also there's like conditional behavior depending what kind of stage I'm deploying to, whether it's prod or dev, and I'm changing the domain name correspondingly. There's a data stack I told you about, represented by the bucket and distribution, and remember those additional things I pointed out, so Route 53 record and ACM, the certificate, right? So whenever you use this SST construct, you don't have to worry about it as much because the author has gone above and beyond to make it super convenient for you. So the only thing you want to make sure is that the domain name exists, okay? The only thing you need to make sure that your zone is there and you own it, okay? You can create records and you can, that's essentially it. And you also want to prepare these child zones, obviously, by creating namespace records and pointing them to the parent domain correspondingly. This is your prerequisite. This is fine to do manually once, like every now and then. It's going to be very rare when you're going to change it anyway, right? So you do that and the stack takes care of the rest of the things for you. And the last piece here is the side stack, which I had to tackle a little bit further because I was doing, like, I was trying to find the parameters that I want to change, like timeout, for instance. I wanted to like reduce the amount of memory allocated for this image optimizer function. It wasn't as trivial because I had to actually modify the plan itself. There's like transform function that is exposed you can use, and then the plan comes out in this like argument parameter, which you can modify and provide back to the function output. Basically, everything is changeable. There are a couple of bugs I found so far, but nothing that can't be fixed. I think it's a pretty decent model to go with if you want to support your like entire full stack app in TypeScript and through various TypeScript libraries. So in order to deploy this thing, you essentially just need to execute the SST deploy operation and provide the stage name. There's two versions of how you can deploy things. If you do it through the deploy command, it's like a production version that's going to be out there, meaning that everything like Lambda will come out as like normal Lambdas, and you'll have to debug them through logs and metrics. But you can also deploy a thing using this dev directive, and if you do so, your Lambdas are going to be mock functions, which will allow you to debug it locally, basically by rerouting traffic onto your local environment. In case of the website, Next.js website, whenever it's an internal package, the way you're going to develop it is that you're going to actually launch it in a dev mode, right? So Next itself has this dev mode, and that is nothing but just a local version of it you can execute. And this is the way, in fact, how you move rapidly. So, but you also have to wrap it around this bind function. So the Next.js, your like a server functions, in fact, can resolve the dependencies you wanted to, right? For instance, the configuration parameters, right? Whenever you like my server function for instance depends on this DynamoDB table and in through the parameter, right? So I'm creating this DynamoDB in another stack, and in order to access my table, I need to know a couple of things about this resource, the name, the project, and so on and so forth, right? So this gets exposed through the CloudFormation export. I can consume it in the server function, right? And the example of it's gonna be probably this page right here. I think I have a service for that. So yeah, and in fact, I'm doing it through another package. So there's package sitting in the core. What I'm using in order to retrieve available posts from the DynamoDB table, but that package depends on the DynamoDB implementation. This is the table name and also the bucket name. So this needs to be bound in the runtime in order for it to work. That's why you will need to build your website, provided that you're relying that you depend on those like SST dependencies. Okay, you have to bind it you have to wrap it around this SST bind directive. Let me actually demonstrate it to you how convenient it is to iterate on the progress. So if you want to change something in your website, what you want to do is you want to launch this command in a debug mode, right? I already prepared this configuration, so I'm just going to use my shortcut for that. So it's going to build it relatively fast because I already built it, and it leverages the concept of iterative building. So it gives you the local host endpoint, which you can use to go to the page, right? So you open this page in your web browser, and let's say you want to modify something like on that target blog post page. You're not quite happy about the layout or something, okay? So I want to change the color, a couple of add additional kind of items here, change the space between the elements. All right, or you just simply debug whether the stuff that you're getting, that you're fetching from DynamoDB, let's say, right, is a correct one. That's what you're expecting. So it comes down to just simply defining a breakpoint where you want to step in. Okay, you put it right here, and then you reload the page, for instance. And your IDE is going to bring up a lot of local stack for you, so they can debug all of the parameters received. So it's quite convenient. Once you are satisfied with the final look, you want this website to work off of the actual production domain name, mikeilaslabin.com. So the only thing I have to do from that point, once I'm happy with the stack, I just have to deploy the website in a production mode, and it comes down just launching this deploy command, which will go through the full cycle of building your NextJS project, the other dependent projects, doing linking, linting, the type checking, and all those fancy things. Since I haven't changed anything, nothing is wrong, so it just proceeds. It leverages the concept of iterative building in case of the deployment as well. So the entire CloudFormation stack doesn't get redeployed, only the difference, right? If there is a difference. Just at this point, it's just bundling some resources. It hasn't gotten to the point where it deploys a stack. Actually, it's there, right? So if we update the CloudFormation stack, we see that it's changing a couple of resources here. Asset replacer. There's some smart logic how assets get updated without needing to deploy some critical or heavy elements of the stack. And let's see how much time it actually takes to redeploy a website. So this is what I've got, and for the desktop version, actually I've nailed the performance. It's 98% mark, which is like really fast. But it could be perhaps because it was served off of the CloudFront, because I already loaded it once in my browser, through my browser. Okay. So very interesting, actually, information, very interesting insight about it. This is how you build it, right? You just like rely on a modern stack, and the stack does all the work for you, so that you have a good grade in the end. So this concludes my, turns out to be a long video, but I hope it's been interesting and exciting, so that you can like use the learnings for your project or your activities, or you can like come up with your personal like website like I did. So, but my goal here is that it's not really hard, to be honest, to put everything together, like, leveraging modern stack, and it's gonna be fast, and you can control both application and infrastructure at the same time using appropriate convenient tools. And I know it's not the work for a single person, but still, right? If you're a small team, it probably makes sense to consider such an opportunity and develop off of. So on this note, I want to thank you all for stepping by, and I hope I will be able to present you something interesting going forward. I've got a bunch of resources right here where I usually stay active, and I'm happy to engage on the matter. I see you next time, guys. Thank you.